Hello, we're back from Easter vacation and it's time to get started on square roots. So I'm going to go through some notes here with you and then I'm going to work through some sample problems, okay? So square roots are also referred to as radicals, and it's because this is called a radical sign, okay? So some notes here. If it's a third root or a fourth root, it's written. If there is no index shown, that's a little number here, it's presumed to be a square root. Okay, just like when we see a variable x that didn't print here. If there's no number in front of it, we know it's a 1. If there's no exponent, we know it's a 1. All right, so that's given when we have a variable. When we have a radical, if there's no index written, it's a 2, it's a square root, okay? Next, let's talk about simplifying square roots. So I put some rules here, some guidelines. These are not problems you are going to enter into your calculator and find a decimal number, okay? We are looking for this written in simple radical form. And that's what this example is here. This is in simple radical form. So as we do this, you're going to always see if you can factor using a perfect square. And I gave you the perfect squares. You probably should know them up through 15 and maybe this one. But I wouldn't expect you to know 16, 17, 18, and 19. Okay, so what a square root means is, when we read this, square root of 4, it means what number to the second power is 4, and that answer is 2. The square root of 9, 3. The square root of 16, 4. These are called perfect squares. All right, these numbers are perfect squares, and we're going to try and factor always using a perfect square. So here are the rules. And here's some examples. We're going to start with the radical, square root of 12. We're going to factor it using a perfect square and another number. Always write the perfect square first. Okay. We look at the second number. We can't factor it as a perfect square, so we leave it. Then we break this into, because this is multiplication, we can just separate these into two things. The square root of 4 times the square root of 3. The square root of 4 is 2. The square root of 3 we can't do. And 2 times the square root of 3 is just written 2 radical 3, or 2 times the square root of 3. All right, let's look at another example. Square root of 72. We can factor 72 using a perfect square to 9 times 8. Then we have to look at the second factor. This 8, can we factor it using a perfect square? And the answer is yes, we can. We can say that 8 is 4 times 2. All right? This is all multiplication, so we can break it up into its separate parts. The square root of 9 is 3. When we find the square root of a number, we don't put the radical sign on it. The square root of 9 is 3. We did the work of the square root sign. The square root of 4 is 2. No square root sign. The square root of 2 is left in here, so it stays here. Outside, these are multiplied, so that is 6 radical 2. Okay? Now let's look at some other problems that I will work through with you. All right. First one, square root of 20. Okay, we can factor 20. We want to use one of these perfect squares. These are the most common ones. That's why I wrote them here for you. So we can factor this to the square root of 4 times 5. Can we factor 5 using a perfect square? No. So this becomes a square root of 4 times the square root of 5, which is 2, right? The square root of 4 is 2. Square root of 5, we can't do. Okay. Let's look at this next one. 27, square root of 27. Well, which perfect square is a factor of 27? 9. So we're going to rewrite this 27, write the perfect square first. 9 times 3 is 27. Can we factor 3 using one of these perfect squares? No. So we break this into its two parts. The square root of 9 is 3. The square root of 3 we can't do. Okay. 48. Now you might notice that 16 is a factor of 48, but if you don't notice that, that's okay. We can factor this. 48 is 4 times 12, right? 4 is a perfect square. Can we factor 12 using a perfect square? One of these perfect squares here. Yes, 4 is a factor of 12, so this becomes 4, and this is 4 times 3. So we have the square root of 4, the square root of 4, the square root of 3, which is 2 times 2, radical 3, so we get 4 radical 3. Okay, let's look at the square root of 18. Now there's a lot of factors for 18. 3 and 6, 2 and 9, 1 and 18, but we always just want to factor it using a perfect square. So I'm going to do this one a little differently. I'm going to say this is the square root of 9 times the square root of 2. Can we simplify or factor the square root of 2 using any of these perfect squares? No. So this becomes 3 radical 2. Okay. We already did 12. I won't do that one. Let's look at this one, the square root of 80. Again, there's lots of ways to multiply to 80, but we only want to use the factor that's a perfect square. For example, does 4 go into 80? Yes, it does. So we're going to write this 4 times 20, right? That's 80. Can we factor 20 using a perfect square? We can. So we'll bring down this. Square root of 20 is the square root of 4 times the square root of 5. Again, we don't want to use 2 times 10 because neither 2 or 10 is a perfect square. We always want to factor first with the perfect square. So for here we get a 2, here we get a 2, and the square root of 5 we can't do, so we have 4 radical 5. Okay. Now sometimes there might actually be a number in front of the radical sign. Okay. So that's just going to hang out there for now. Can we factor 32 using a perfect square? Any of these perfect squares? Well, you might know that 16 times 2 is 32. But if you didn't know that, we do know that 32 is 8 times 4. So the square root of 32 is the same as the square root of 8 times the square root of 4. Right? That's right. I should have written the 4 first and the 8 second. Sorry, my bad. And then we look at this, the square root of 8, and we can factor that again to square root of 4, square root of 2. So we'll bring down these other parts. And then let's simplify. We have the 4 hanging out in front. Square root of 4 is 2, so that's outside the radical sign. Square root of 4 is 2, that's outside the radical sign. Square root of 2 we can't do. 4 times 2 is 8, times 2 is 16, radical 2. Okay. 20. I feel like we already did 20. We did. So let's look at another one. Let's look at this one, 45. So negative 5 times the square root of 45. So we'll bring down the negative 5. It's outside the radical sign. We'll factor 45 as 9 times 5. Can we factor 5 anymore using a perfect square? No. So what we have here, we'll break this up. We have the square root of 9 times the square root of 5. Bring this down. Square root of 9 is 3. It's outside the radical sign. Square root of 5 we can't do. So we multiply everything outside with everything outside, and whatever's left inside we keep. Okay? Let's look at number 12 here. Okay, we have a 3 out in front. 25. Square root of 125. 25 is a factor of that. So we're going to rename this as 25, square root of 125, as 25 times 5. Can we factor this using a perfect square? No. So we'll break this up into 2 parts. Bring down the 3. Square root of 25 is 5, no radical sign. Square root of 5 we can't do. It stays inside the radical sign. We can multiply these factors that are outside and this.